The broadcast is now starting. All attendees are in listen-only mode.
Welcome to our third webinar of the DocYard webinar series. Today we look at technical concepts, looking behind the scenes of DocYard, after we had some generic and conceptual webinars of DocYard. I want to introduce you to Armin Ortmann. He's our CTO.
Hello, good afternoon.
Armin is obviously doing most of this more technical webinar on DocYard today. My name is Carsten Heiermann. I am the CEO of LuraTech, and I'm here for managing your questions, answering additional questions, and also helping Armin on his presentation. There are some organizational hints. You can always ask questions if you have. Using the questions window that you have in your GoToWebinar software, or even the chat window that you have in your GoToWebinar software. We try to monitor that and answer questions that are easy to answer during the webinar on time, in time, immediately. And you can be sure that if your question is not answered during the webinar, we definitely return to your question and answer it after the webinar in writing. Some of the questions I also might ask loud to Armin in order to get an answer from him directly. Okay, it's the third webinar today. After we had one very conceptual webinar and one specially catered for scan service businesses, today we're talking about the technical concepts. Okay, Armin, let's go.
Okay, so we'll start with an overview, and I must also emphasize that we are starting somewhere in the middle with this webinar. We're not reiterating all the basics. If you missed one of the preceding webinars, we will broadcast the links to the recordings of these webinars later on. But for now, we assume that you do have a basic knowledge of what DocYard is all about and what the DocYard cockpit and the workflows look like. From that point, we will have a more detailed view at DocYard components, that is the software components that make up for a DocYard installation, namely the cockpit, the master database, the module managers, and the modules. We'll describe which components handle which tasks, what happens when a job is started, which data are being transmitted, and what finally is stored in the DocYard database. Because you hopefully know that all the configuration and logging data in the DocYard environment is stored in a database in a unified fashion. In the second part, we will have a more detailed look at the module API. That is the programming interface for developing a module. And we will revisit that. We will explain what the DocYard infrastructure offers for module implementers. We will also have a look at integrating native SDKs and DLLs, and also at the integration of external and interactive tools. We will conclude this webinar with a short look at a snippet of source code. I will basically just quickly glance over some module source code to give you an idea of what that looks like and how complex it is. And we will also see a short example of an MS Access created database report that directly queries the DocYard database. So for the software components, there are several of them, and on the one end, basically there are the modules. These are the real functional components. These are the places where things happen. So whenever something is really converted, some data is really being processed, pages are being reformatted, images are being resized, documents are split or merged, all of that usually happens or generally happens inside modules. The platform, the installation itself, the underlying DocYard infrastructure is more or less agnostic to the contents of your data. So it will forward your data and make sure nothing gets lost, but it will not really look at it, and it will not really care whether it is a PDF document with several pages that is being transmitted or whether it is just a bit of XML string or whatever. The modules are hosted by the module managers, and therefore you can have quite a lot of modules on a single machine, and they can run in parallel, but you have only one module manager, and the module manager really is the host, the foundation, the basis that enables the modules to run. The modules by themselves are mere software components. They don't really have means of existing on their own. And the module managers, one per physical, or as it says here, virtual machine, because they run just as well on virtual machines, are controlled and conducted by one central master component. So while there may be one, or while there is one module manager per machine, and therefore there may be quite some of them, per installation there is only one master and there is only one database component. These are central and unique. And then there is the cockpit, and the cockpit really is the GUI application for centralized control. It really is the face of DocYard. It is what you usually get to see when you are running such an installation. This little diagram, we use it a lot to outline the distribution of these components over several computers. So you have a schematic network here which basically links 4 server machines. Those are these big boxes, and one desktop machine, and the desktop machine runs the cockpit in this case. One server runs the manager and the database, and 3 others run the module manager. There are different ways of distributing these components throughout a network of computers. We will have a special slide for the details of such a distribution later on. Concerning the functional distribution, the functional breakdown, we have developed the following metaphor or analogy. Imagine an orchestra, and imagine a DocYard installation being an orchestra able to play a variety of tunes. What you then have is the cockpit as the composition workshop, as the place where a tune is or a set piece is composed, and you have the master somewhat equivalent to a conductor. So you pass your piece that you want performed, you pass it to the conductor. The conductor has several musicians. Actually, in our case, the musicians are very talented. Each one of them can play quite a variety of instruments, and they can even play several instruments simultaneously. And the conductor is responsible for telling each musician what to play and by which instruments to play it. And on the side, you have an archive, and the archive basically immediately stores all the compositions that are being made and all the recordings of all the performances. And then the whole thing being even a little more complex, this orchestra is also able to play several tunes simultaneously. So you can compose several pieces, and they can somehow be performed in parallel without getting confused or mixed up. So maybe it's more like a production studio, actually. To stick to this analogy, in this view, the modules really are the instruments of the orchestra. They are the tools by which actual tunes are being played. And we split this up here into a functional view and a technical view, and the functional view is really the modules are the places where processing of your data takes place. And here are some examples. For example, processing at the most basic level is file input and output, but it can just as well be document scanning, indexing, conversion between several available document formats, standard image processing such as rasterizing, scaling, rotating, the various color conversions. Of course, compression, such as our brand MRC compression, and OCR and form recognition, and so on and so on. What's not explicitly mentioned here, we do have quite a bunch of lightweight modules which basically do very simple and straightforward and generic tasks, such as branching, that is routing documents with different characteristics, such as different color spaces, different image sizes, all sorts of other differences in properties along different paths. So if you want to handle your, say, black and white documents differently from your color documents, you can simply branch and split the workflow and route these documents to different destinations. And equally straightforward, for example, you can copy arbitrary objects and then do different things with the two separate copies. That's just two examples of very simple generic modules. The technical view of the modules is as follows. Modules really are object-oriented classes. I hope you are somewhat familiar with the object-oriented programming paradigm. We are using the Microsoft.NET framework for DocYard. Therefore, these are .NET classes. We are usually using C# to program, but of course you could use other languages such as Visual Basic that are supported by Microsoft.NET. Actually, there is quite a list of supported languages on that platform these days. And in the object-oriented paradigm, all the modules derive from a common module-based class. And this class, of course, is very prominent in the module API. If you have these classes, they are basically bits of code in a DLL on your file system, and the module manager is responsible for loading these DLLs on demand and instantiating, that is, creating instances of the modules as required, and later on disposing of these instances when they are no longer required because the job they belong to has finished. The DLLs as such are either COM DLLs or preferably .NET assemblies, and of course internally they are free to reference arbitrary other DLLs. That is usually where your existing legacy libraries and SDKs come into play, as it is with our standard LuraTech SDKs, some of which we have already wrapped into DocYard modules. And basically, inside a module, you're more or less free to do whatever you can program. That is a bit generic, but modules are absolutely free and allowed to communicate with external processes. So if you have, for example, an OCR engine that's running as a service somewhere and you cannot directly wrap it into a module via an SDK, you can of course initiate the communication with this external service from inside the module. We have an example implementation, for example, for a service that does PDFA compliance checks. That's just one example. Concerning the input and output, modules receive the data through their input channels. They are usually drawn on the left side, and they provide their output through the output channels on the right side. So the general direction in the workflow diagrams is left to right. And of course, modules can have further properties, most prominently configuration values, but also, for example, licenses and other properties that are managed also by the DocYard infrastructure. The module managers, again, these are the hosts of the modules. They are basically the musicians picking up and playing the instruments. I mentioned some of this already. They create and dispose the modules on an as-needed basis, so you don't have all the modules loaded and instantiated at any given time, but they are really just present whenever they are required. The module manager also provides for the connections between the input and output channels, which is really critical if such a connection crosses a computer boundary, whenever it links module managers residing on two different machines. And the module manager receives and propagates log messages by the modules. That is, the module manager receives these messages and makes sure, for example, that they end up in the database and possibly are logged somewhere else, for example, on a console or in a log file. Technically speaking, oh, there's a slight typo there. Sorry for that. There is one module manager per virtual machine, and that is running as a Windows service. That is, it is configured to automatically start upon booting or restarting the computer, and at that point it actively connects its master. So the module manager is a service application that's meant to run in the background. It does not have any GUI on its own. The most you may see of it is a log file or a log on a console somewhere. The master, the conductor of the orchestra, this is the really central component. It has to keep track of what the module managers do, how many of them there are, whether they are active or idle, and based upon such information, it makes sure that jobs are distributed properly onto the available module managers. It also maintains a connection to the database, and it is also responsible for a bit of the monitoring and logging that's going on, and it is the central component for administering and distributing the licenses. So the master really has the central license information which controls, for example, how many pages are still available for a certain task, or how many have been consumed already, or whether there is a limit to the number of module managers that can run simultaneously, or whether a certain module is limited to a certain number of instances. And again, the master is implemented to run permanently as a Windows service, and therefore restarts automatically along with its host computer. The cockpit. The cockpit is, as mentioned, the composition workshop. It's the place where actually the tunes are created that the orchestra can then play. And that already includes a few metaphorical illustrations, because not all of the tunes have to be played all at the same time. You can create compositions way beforehand, and maybe you can even extract compositions from recordings that of things that were performed in the past. Basically, all these analogies hold. All that is possible in the cockpit. With that said, you have the chance, the opportunity to create and administer workflows in the cockpit, and of course you can then, for any of these workflows, start one or more jobs, and the jobs basically are the tunes, your compositions being performed by the orchestra. And as mentioned, the cockpit provides access to all current and all past job data as it is recorded in the database. So whatever you do, whatever you performed as a job is not lost, but is recorded in the database and is available for later inspection, for performance analysis, and for basically recreation for an encore performance by the orchestra. Technically, the cockpit is a standard .NET GUI application. It is interactively started just as any other such application. It contacts the master and communicates with the module managers via the master. Actually communicates with the database directly these days, but that is not mentioned here. The database, that's, as mentioned, the archive. And to mention that again, it stores both the composition, that is the configuration information such as workflows and the configurations of the individual modules within the workflows, and the performance data, i.e. the logging information of all the currently running as well as all previous jobs. And we'll later see in this little Microsoft Access example how you can use standard tools to draw reports from this performance data. So, for example, you can easily inspect the number of pages that were produced in a certain job, and you can just as well inspect the number of errors there were, or whether any files could not be converted at all, and so on and so forth. Technically, we again have a Windows service. The DocYard Database Manager is really just a rather small front end for a standard ODBC database. So basically, any ODBC database can be used as a real database in the background, and therefore you can either use our default that is directly delivered and optionally installed with DocYard, which is PostgreSQL, which is, in our view, the most powerful freely available database, or you can of course use an existing ODBC database in your organization, such as Oracle or MS SQL or DB2, just to name a few standard brand names. And as already mentioned, you can use standard ODBC reporting tools such as MS Access, Crystal Reports. You can even use Excel to access the data and then do computations, comparisons, compilations that actually make up human-readable reports. Carsten, any questions, anything I may have forgotten, anything to mention for now?
So far there are not too many questions that people asked. I can only once more encourage you all, if there's any question, technically or not, just type them in the question section and we pick them up and answer it immediately. There's one question, of course, which is not really a technical question, but it might be raised due to your very technical presentation that we have today here. And the question is whether DocYard is designed for system integrators only, or whether it also targets towards end customers' usage. I mean, I might as well give you another minute to rest and answer the question myself.
You can do it much better than I can, so go ahead.
Yeah. So, of course, seeing a technical presentation like today, this might be a valid question, but today's presentation is more or less catered to the audience group of system integrators who are going to create integrated solutions, projects, and work with end customers on delivering them turnkey solutions. But that's only the nature of today's webinar. DocYard is definitely designed to be an integration platform for existing technologies in the area of document conversion in general. And these use cases obviously happen in the scan shops or document in the input management of larger enterprises, but also especially at scan service providers or business process outsourcers, who are definitely a target group that we address with our DocYard offering. I hope that answers the question that we had here. If not, just feel free to type in additional questions in the questions section of your GoToWebinar software. Armin, your break is over. Go ahead.
That was actually more than a minute. Quite refreshing. Okay. Now, for a bit more of the functional description, what really happens when a user creates a workflow in the cockpit? Well, of course, they have to pick modules, they have to draw channel connections, and certainly some of the configuration values of the modules should be set. And then basically the workflow is ready to be started as a job. And whenever someone does this by simply clicking Start Job within the cockpit transmits this entire information to the master, and the master then goes ahead and determines which module managers to concern with executing this workflow. There's actually, at present, there is a degree of freedom for the user. They can really tie a workflow to certain individually named module managers, or they can merely tell the platform to run it where the platform thinks it fit to run, and we are working on extending the options one has there. Of course, the master has to take into consideration the number of installed and licensed modules. It's easily imaginable that a module manager cannot run a module which is not available at the corresponding computer, which is not really installed as a DLL, and possibly also job priorities and the workload of the individual module managers come into play. So of course the platform tries to run as many things in parallel as possible and to fully exploit the resources of all the module managers, but this of course is also just a heuristic process that runs, and it tries to determine where to run the job best at the moment when it is started or at the moment it becomes active. And the module managers, once they have received the orders to run a certain workflow, they then go and instantiate the modules, they load them from the DLLs, and they create the channel connections, and once that is done, everything is ready to go and the workflow starts to run. We see this again in this diagrammatic view. We have this very simple workflow comprising only 4 modules. If that's transmitted to the master, in this example the master may, for certain reasons, decide to run 2 of the modules on the one module manager and 2 of the other modules on a different module manager, and therefore it's of course very important that this connection joining the 2 computers is also created properly by the infrastructure. To mention some more details, modules can be instantiated on several module managers. Jobs can really run sequentially or in parallel and distributed across several module managers. The platform itself is able to run one and the same modules several times on the same machine. Our implementation is thread safe. It is able to exploit multi-threading. It is also able to handle libraries which by themselves are not thread safe. And one thing that needs to be mentioned, while the job runs, this distribution, this breakdown of a workflow onto certain physical machines, that cannot modify while the job actually runs. One more detail, input modules can either just consume a given set of input data, or they can be time triggered, that is, they can query certain things such as an input folder or a mail server or a database at reoccurring intervals, and the connection infrastructure automatically propagates all the data. So whenever you are concerned with a module as an implementer, as someone looking at the inside of such a module, it is totally insignificant for you, for example, whether the data comes in through a local connection, as in this case, or whether it comes in through a remote connection, as in this case. And the same holds for your output data. Internally, you just have to implement the function that receives the data and provides the output data. The infrastructure will do all the propagation and will make sure the data arrives at its destinations. And one more thing to mention here, the data can, of course, be saved to files at any given point within a workflow, but it does not have to be. You're not looking at an infrastructure here that at every given point creates temporary copies on your file. and transmits everything back and forth to a file service or a file storage. But really, if we draw such a connection, that usually means direct communications over your network between these two machines, between these two modules. Okay, parallel execution, we had that before. Concerning the distribution of your DocYard components throughout...
1 second, please. Armin?
Sorry?
1 second, please. Before you actually move to the next topic, there is one or two more questions that I might want to ask you that came in from our audience.
Sure.
The first question says, which resources are chosen? In example, there are two OCR modules of the same kind. So what is DocYard going to do? And maybe the second part of the question gives a little bit direction of what the listener is looking for. Can it be manually influenced? An example for human interactive modules.
The answer, especially to the second question, is yes. The one option that you have is directly configure within a workflow where a certain module is to run. So if you have a machine that's called A and a machine B, and both have this OCR facility available, in your workflow you can directly say, oh, I want this to run on A and I want that to run on B. And then the next question, of course, is whether your OCR module is capable of running several jobs in parallel, or whether your OCR facility can only do one thing at a time. If it can run several things in parallel, you can have several modules and several workflows using the OCR engine on machine A, and the same with machine B. And you can also have one workflow that uses both. That may be a bit confusing, but that's the answer I can give right now. And
okay.
If you specify nothing explicitly, the infrastructure will determine whether A or B has less work on its plate, and will by that result try to schedule a job automatically.
Okay, thank you. Once more, if this doesn't really hit it on the head as an answer, just specify your question or ask more questions using the questions section in the webinar software. Thank you, Armin. And go ahead, uninterrupted now.
Oh, you're absolutely welcome. It's very hard to cover all the general topics within one presentation, and therefore all the questions are, of course, welcome. At that point, at least I know that one person is interested in what I'm saying. Concerning the distribution of the components, I mentioned that before. The components can really be distributed more or less arbitrarily across computers. There is these two rules that hold: one module manager per machine that is really acting as a workhorse, that is really intended to process documents, and the other rule is one master and one database only, but that of course leaves quite a degree of freedom. So one thing on the one hand is a complete DocYard installation is quite possible on one machine. Actually, we do this all the time, for example, for testing or evaluation or demonstration purposes. We don't, if somebody goes to a trade show, of course, we don't really create a network, and we don't install 5 virtual machines on one laptop just for demonstration purposes, but at these points we really just put everything on one machine. In a production environment, it is more likely to be the other way around. That is, you will have several computers with module managers, and then one of those may also run the master, or one of those may also run the database, or these two may even run on completely separate machines, and again the cockpit may run on still a different machine. The process that makes this possible, we call it discovery. It provides for all the components to broadcast a signal throughout the network and find and contact each other, and therefore create a proper setup. So this should happen without explicit user interaction. You don't have to go to any of these machines and always explicitly tell it where to look, but that is configured once, and then basically all the machines should happily connect and interact with each other. Okay, and again, the DocYard infrastructure handles all the inter-process communication. It makes sure that all the data are propagated and end up where they belong. That brings us to the second part, and I need to rush a bit because we are already past half an hour. Concerning the DocYard module API, we'll have a short look at real source code in a minute, and that really underlines what we say here, that usually a few hundred lines of code totally suffice to wrap library functions to connect an existing SDK. If, on the other hand, you want to implement something more complex directly in a module, that can, of course, require quite some more effort, but it's possible, of course, just as well. The basic things for a module to do is you have to define these input and output channel. In this standard case, you have one input, one output. You have to specify configuration values. Those are the values that in the cockpit are shown in this properties view. So in case of this PDF rasterization module, you have, for example, a rendering resolution, and you have an option to rotate landscape pages to portrait orientation. Those would be boilerplate examples of options, and of course you can have an icon, and you can have various international translations of all these settings. So you can supply a set of string resources to localize your module. Also central is the so-called central processing function process data objects. That's really the function you need to implement if you want your object to do something, and you can augment that by further implementations, for example, to do something special once the module is created, such as connect an external resource or connect a service or open a file or whatever. And on the matching side, when the module is finalized, that is when it gets destroyed and deleted from memory, you also have such a hook to add further functionality. And of course, wherever applicable, you can add licensing to your module and restrict its overall usage. Concerning native SDKs and DLLs, that is things that are written in more traditional languages for the Windows operating system, such as C or C++, they don't directly run in this .NET environment. They don't have this .NET runtime. They don't use memory management, etc., etc. The required or the recommended method to integrate such things is to write a so-called .NET DLL wrapper. That is a thin layer of wrapper code that basically translates between this native environment where the original DLL runs and the .NET environment. That's a really straightforward thing to do, and usually the most easy way to tie these two worlds together. As an alternative, you can also directly access the module API via the COM implementation platform. That is something that is residing in the C, C++ world, in the traditional native world, but Microsoft also provides for a direct interface, and that can also be used in DocYard. Things that the DocYard module infrastructure provides you with whenever you implement a module. Well, of course, there is this module base class. Actually, there are several flavors of this base class. So you have external modules which provide extended support for connecting to external processes. And you have this interactive module base class which supplies quite some support for creating a module that also involves interactive process steps that displays a user interface for a human user, where the user can do such a thing such as quality control or checking whatever results you have, or indexing or typing in correction strings for, say, OCR or form recognition correction. Of course, there is a set of standard types to pass along the input and output channels. This is an object-oriented model, so it is extensible in an object-oriented fashion. You can create your own derived data types wherever necessary, and the platform will handle them just as well. And of course, there is a type set for the configuration value. Then the interface also, the API also provides interfaces for standard facilities such as the licensing, so your module can query its license in a standard fashion, and it can also post its log messages in a standard fashion. So you basically just have to make one function call, and you are not really concerned with the post-processing of the logging, what goes to the database, what ends up in a log file, what is displayed to the user in a console, etc., etc. And that's it with the presentation, and I have hopefully a few minutes left to show you the two practical bits, which is, yeah, Carsten?
3.5 minutes you have.
3.5 minutes, okay, so I'll rush a bit. Concerning the module implementations, this is a sample module that we also ship with the API, and it's really the most simple implementation you can create that will actually be recognized and be able to run as a module. So you have a basically non-operational implementation of process data object. This one will really just forward all the objects it receives, but of course you see this would be the point to do something more evolved, and you have at least definitions of one input channel here and one output channel, and you could add further configuration property values at this point here. To take a look at this rasterize module we have just mentioned in the presentation, here you see that things are a bit more involved. The properties section shows you all the configuration properties that were in the presentation, and this thing has a name and a description and an icon and so on. And of course, it queries its configuration variables, and it can do some more evolved things in its process data object method. So for example, it can decide whether to output single pages or multi-page TIFF images, and it can also treat different color types in its objects differently. And to scroll to the bottom, you see that all of this still using, of course, the GoScript PDF rasterizer in the background, but all of this in shape of a module only takes 300 lines of code. So basically, in most cases, we found ourselves implementing one class with well below 1,000 lines of code to create a module for something that is already existing as an SDK or a library. Okay, to quickly show you a bit of the reporting, I have a DocYard installation on this machine, and it's still more or less virgin. It only ever ran these 5 workflows, and as you see here, the workflows only also process some 2 pages, and we have this very straightforward MS Access example. I hope some of you at least are familiar with this. This is really a tool for querying such database information and creating human-readable and nicely formatted reports. So you see here in this descriptive string, we're really using ODBC as the interface to query the DocYard database. We have this straightforward view where you could filter the output a bit. I don't do that right now, but what you directly see is you get a view of the jobs that ran here. I could run the same job over again, and that's pretty fast because it really only runs these two. Come on. Typical thing, doesn't happen. Okay. So due to the lack of time, I won't really go and check what went wrong here. I can only ask you to trust me that whatever happens, you see the examples from the earlier webinar today here reflected in this report, which has just been created. And of course, using such queries for the tables that the DocYard database hold and which are of course well documented, you can draw such reports and you can create sums, for example, of the number of workflows that ran on any given day or in any given week or for a certain customer. And for example, something that is not in here, you could also check for errors. So if this workflow should have processed 7 pages and only 5 came out, or 2 came out, as in this case, then of course you would have to have a report that shows you that not all of your files were processed successfully. Okay, Carsten, anything else? I think we're really running out of time now.
Yes, we are. So maybe we'll start the wrap up a little bit now. I think we learned a lot about the architecture of DocYard today, and how different it might be from other systems, including the way to transport data through the network and everything else. I think we learned a lot about the API and could really see from even the source code level how easy it is actually to integrate an existing technology as a DocYard module into DocYard workflows. So I think, and also we saw the reporting, how detailed the recording of all the logging data is then for all these components that you might integrate into DocYard workflows. In a unified way, you get all the information that is needed, all your process data, get it stored there and can create even custom reports on it, so you really able to have full access and have full knowledge about beginning to end of your whole production facility used for document conversion there. Yeah, thank you very much, Armin, for that presentation. Also, thanks a lot to our audience today for listening. Some more hints. You think the webinar was too technical for you today, or you're missing some fundamental concepts? That might be the case because you missed the webinar 1 and 2 of our series. But there's good news. You can simply send us an email. Maybe, I mean, you open up a slide again with an email, showing an email.
This would be it?
Yeah, here it is. Okay, simply send us an email or send an email to your known contacts at LuraTech and ask for a link towards the recorded webinars 1 and 2 of our DocYard series is here to learn a little bit more about the basics and everything else. Of course, if you want further consulting or individual demos or whatever, do not hesitate to contact us. We are ready and prepared to do that. And then, last but not least, please fill in the questionnaire that you will see when you're leaving the webinar here, and help us improve in our webinars in general. And also, you can use that questionnaire once more to write down your additional questions that you might have or that you might come across. And just be assured we are going to answer them all after the webinar. Thank you all very much, and I hope to talk to you soon. Have a good day. Bye.
Bye-bye.